Yes, bete. Now we must start the topic. Sorry for little inconvenience. I was little busy with the devices. Yes, it is limits and derivatives, and in limits and derivatives, this unit is known as calculus, chapter 30, and in this think about the different conditions at different points. We are going to think about the limits. Like I was telling you, limit x tends to 0, 2x plus 3. So this limit x tends to 0, this limit x tends to 0 says us that the value of the x is almost equals to 0. The value of x is almost equals to 0. This could be little less or little above than x. But for the simple functions, I could say it will be 2 into the x is 0 plus 3. So the value of the function will be 3 at x equals to 0. One more example I'm taking, then I'll tell you the ultimate benefits of this. So one more scenario we are going to take. This is now limit x tends to 5. Function I'm taking x plus 2. So simply right now also I'm going to put the value of x as 5. So it will be 5 plus 2, that is 7. For the given conditions, we are supposed to put the value of x simply. But exactly what is the meaning of limit, that we are not able to understand yet. So that I'm trying to explain you what is exactly limit condition. So one example, we are taking limit of x tends to 2 fx. Limit of x tends to 2 fx is, see, limit x tends to 2 means there are two conditions. Two conditions means one is x is little less than 2, other is x is little more than 2. That is limit of x tends to 2 negative. If we are thinking the number line, see on this number line somewhere 2 will be lying. So we could go, it is almost equal to 2. I said almost equals to 2. It is not exactly equals to 2. Almost equals to 2 means little less or little more than 2. It is little less or little more than 2. So this indicates the two situations, that is left hand side and right hand side. So one I'm saying left hand limit, other one I'll say right hand limit. Left hand limit, limit x tends to 2 negative. Limit x tends to 2 negative. Function will be same fx. And for right hand side, limit of x tends to more than 2 means a bit more than 2, that is 2 plus for the same function. Whenever the situation will not be in our favor, mean directly we won't be getting the answers. In that case, try to implement left hand limit and right hand limit. If in case left hand limit is equals to right hand limit, if in case left hand limit is equals to right hand limit, that indicates the function exists. Otherwise the function limit does not exist. If left hand limit and right hand limit both are equal, if left hand limit and right hand limit both are equal, that indicates the it exists for the given function. Otherwise limit does not exist for the above given function. So now when we think about these situations, so let me tell you first of all, directly we are reaching to the first exercise. Try to see Question I'm taking, question number 1 similar I have taken, 2 is very much similar, so I'm not going to do. Third I'm doing. It is limit of x tends to 1, sorry, r tends to 1. Limit r tends to 1 pi r square. This indicates we need to put the value of r as 1. So that will be pi into 1 square, that is pi. If we think left hand limit and right hand limit, that is not required in this question. But if you are thinking, then think what we are supposed to do. Left hand limit, that is limit x tends to little less than 1 negative. Fx means pi r square. Whatever function is given, that is said as fx. So r we need to put less than 1. So pi 1 minus h square, where h is a very small thing, a very small variable. It is almost equals to 0. So after some time I'm going to put it as 0. So it will be pi 1 square plus h square minus 2h. Now put h as 0, it will be pi, that only. Same for right hand limit. When we are going for right hand limit, directly limit of r tends to 1 positive. For right hand side, whatever limit is given, little more than that. For left hand side, whatever limit is given, little less than that. Function is pi r square. R we are going to put 1, so it will be h tends to 0 pi 1 plus it is na, so 1 plus h2 whole square. Limit h tends to 0 pi 1 plus h square plus 2h. Now we are going to put h as 0, so it will be pi into 1 plus 0 plus 2 into 0, that is pi. So left hand and right hand limits are giving us the same value, that is limit exists. So directly we could do this also. For you, you will be doing it directly. But you must keep in mind similar questions will be asked in the exams also. We need to put the values directly. These values we could put for a long time, but after a certain limit, we will be getting problem. Like right now, I'm doing question number 5. Limit of x tends to -1. X to power 10 plus x to power 5 plus 1 upon x minus 1. This is the condition. Now we are going to put the value of x as -1. Directly I am putting. So it will be -1 to whole power 10 plus -1 to whole power 5 plus 1 on -1 minus 1. So it will be 1 minus 1 plus 1 upon -1 minus 1. This 1 to 1 cancel, it will be 1 upon -2 or -1 by 2 is the result. But now when I'm going to question number 7, now see, till now we were putting directly the value and we were getting the answer. When I'm reaching question number 7, see this thing. Now a concept is coming. Limit of x tends to 2, 3x square minus x minus 10 upon x square minus 4. For this particular question, now what we could do, if I am putting the value directly as, then what it will become? 3 into 2 square minus 2 minus 10 upon 2 square minus 4. 12 minus 12 upon 4 minus 4 it is coming 0 upon 0. Whenever in the question 0 upon 0 comes, whenever in a question 0 upon 0 comes, whenever we are finding in a question 0 upon 0, this is the key point. Whenever in a function we are getting 0 upon 0 or somewhere something upon 0, whenever in a function we are getting 0 upon 0 or something upon 0, in that case we need to change the track. This could never be the answer. So we have to change the track. Now, how to change the track? That is a big thing. How to change the track? So for changing the track, let us think. This is limit of x tends to 2. Now we must factorize it. We must factorize it. How to factorize? X square minus 4 can be written as x square minus 2 square upon 3x square minus 10. 3 and 10 will be minus 30. So minus 30, 6x and 5x. So what I could do, limit of x tends to 2, 3x plus 5 and x minus 2 upon x plus 2 x minus 2. Denominator a square minus b square, that is a plus b, a minus b. Numerator we have used splitting the middle term, that is factorization method. Now what we find, x minus 2 to x minus 2 will get cancelled. After this, now if we will put the limit x tends to 2, we will not get 0 upon 0. Let us see. 3 into 2 plus 5 upon 2 plus 2. So answer is coming 11 upon 4. So this will be the answer. Whatever we were thinking before this, that was giving us the result as 0 upon 0. We were getting result as 0 upon 0. But 0 upon 0 can never be the answer. So what I was doing, I have changed the track. So after changing the track, I have got the answer as 11 upon 4. This will be the final answer. This will be the condition. We will never give answer 0 upon 0. So for that, such conditions we need to apply. Now I am giving you introduction to one formula. Today only one formula I am going to introduce. You have to remember this formula. After this only we will be able to go further. So taking care of this formula is required. See now, it is limit of x tends to a. Limit of x tends to a, x to power n minus a to power n upon x minus a. X to power n minus a to power n upon x minus a could be written as n a to power n minus 1. This is the formula for the limits. Must remember, if limit x tends to a is x to power n minus a to power n upon x minus a, this will be equals to n a to the power n minus 1. So it is one of the very good and important formula. A very simple question based on this I am doing for you. So that I'm taking, like the question is given, limit of x tends to 1, x to power 10 minus 1 upon x minus 1. If the question is given like this, then I want to convert it into this form. This could be written as limit of x tends to 1, x to power 10 minus 1 to power 10 if I'm writing, there is no issue, upon x minus 1. So when we are comparing this particular condition with the formula, I am finding a as 1 and n as 10. I am finding a as 1 and n as 10. So in this condition, the identity will be n, that is 10, a, that is 1 to the power 10 minus 1. So it will be 10. So what is happening? The value of this specific function, the value of this specific function will be 10. I suppose we are able to understand this thing. So only we need to remember this identity. If you will be able to remember this identity, you will be able to do question based on it. One more question I'm taking based on it, you will be able to understand little more better. Limit of x tends to 0 under root 1 plus x minus 1 upon x. I want to convert it into the same form. I want to convert it into the same form. So what I should do, limit of x tends to 0 under root 1 plus x minus 1 upon 1 plus x minus 1. Why I did this? Over here also I must add first of all. Plus 1 on this side, plus 1 on this side. So it will become limit of 1 plus x tends to 1. Now it will be 1 plus x to whole power 1 by 2 minus 1 to power 1 by 2. If I am writing, you don't have any problem, I think. Upon 1 plus x minus 1. Now see, it is becoming limit of x. X is now x plus 1. So limit of x plus 1 tends to 1, x to power n minus a to power n upon x minus a will be n a to power n minus 1. N is 1 by 2, a is 1 to power 1 by 2 minus 1. But 1 to power whatever is there, that could be said as 1 only. So it will be 1 by 2. Answer will be 1 by 2. So this is one of the example I have taken from NCERT. Must think about such situations. These are important, and these situations mainly they will be asking in the exam. These questions are always asked. So must practice such type of questions. Keep in touch with these type of questions, then only you will be able to do. So main thing, again I'm telling you, limits is one of the very important topic. It is a topic which we have to practice. It is important for the coming classes also. So keep revising this